All right, this is the quiz for Unit 4. So number one starts off, label the relationship in the table as either direct or inverse. So we've got one part of a question. Then it says create the equation for the relationship. So we got two parts. And then over here, fill in the missing value in the chart. So we have to do three things for each part for these tables. So if we look at table A, what we want to do first is decide if it's direct or inverse. So the easiest way to do it is to check if it's direct. If it's direct, you're going to multiply by the same thing every time, or divide by the same thing every time. So here, 2 times 5 is 10. If I try that over here, 20 times 5 is not 1. So it doesn't work. So this one's not direct. This one has to be inverse. All right, well, if it's inverse, then we know that we have the equation k is equal to x times y. So that's the idea, is we have to figure out what k is. So we can pick any one of these columns. Well, probably not this one because we don't know what the y is for this one. And we're going to find out what k is. Now, if I look at all of my choices, probably the easiest is the 20 and the 1, but since I already wrote over there, let's look at 5 and 4. So k equals x is 5, y is 4. So k is equal to 20. So that means that the equation is 20 equals xy. So just like before, when we were trying to solve for a for all those parabolas, the idea here is to solve for k, find out what k is, and then leave x and y as x and y. Very similar to those parabolas. Last part then says fill in the missing value in the chart. Well, now that we know that 20 equals x times y, we can say 20 equals x is 4 times y, because we're trying to figure out what this y would be. All right, well, we'll divide both sides by 4, and we get 5 equals y. And so that's our result. So we've answered all the questions that we have there. We're going to follow the same process for part B then. So if I try to multiply, 1 times 6 would be 6. If I try to multiply over here, 7 times 6 is 42. So that works out. So that means that this one is not going to be inverse. This one is going to be direct because we're multiplying. So if we're doing direct, the equation is not k equals x times y. The equation is going to be y equals k times x. All right. I can pick any ones. Again, I think this time I'm going to come over here because I like when I've got 1. 1's a pretty nice one to work with because I can say 6 equals k times 1. I don't really have to divide both sides by 1. We can probably see that 6 is k. It's what we're multiplying by. So our equation that we can write is going to be y equals 6x. So that's our equation for that one. All right. So then we got to get the missing value in the chart. And I think I'm going to do that work over here because here now we know x is 5. So y equals 6 times 5, which is just 30. So we can figure that one out. Then for part C, again, we're going to do the same thing. We got to decide if it's direct or inverse. I can't pick the first one. Again, I could pick any two just to double check. This one looks like it's kind of tough to do, so I'm going to skip that one. And I'm going to say over here, 2 times 125 is 250, because I know that one. If I didn't know, I could always divide to check. To go from 3 to 375, if I tried it, 3 times 125 is 375. So that does work. So looks like we're good to go. So this is another direct one because they both worked. All right. So then we know our equation is going to be, if we looked at the pattern, we see we get the 6 here. So we're just going to pick 125. So 125x. Again, I could run through the whole process again. I could write down y equals kx. I could pick one of these. And again, if I'm going to pick, I probably would pick this one. 250 equals k times 2. Divide both sides by 2. And we can get k equals 125 that way. But you can also just see it. The direct ones are kind of nice that way. For the last part, then we have to find out what goes in this part in the table. So we know that y is going to equal 125 times 0.2. All right, well, 0.2 is the same as 1/5. So 1/5 of 125 is just regular 25. There we go. And that's everything that we got. So we're all set with number 1. And the big key here is knowing the equations. Inverse is the k equals x times y. Direct, y equals k times x. All right, for number 2. This time we're going to let x and y vary inversely. So they already tell us we're doing an inverse relationship. So we already know we're going to have to do k equals x times y. So it says write an equation that models each inverse variation. All right, so that seems very similar. That seems like that's what we did before. We just need to get the equation. And then find y when x equals 10. So again, that seems just like the chart, except instead of a big chart, they're just telling us to find it whenever x is 10. So shouldn't be too bad. Let's do it. We know that k equals xy for all of these. So I can say k equals 7 times 2, x times y, k is 14. So now that I know 14 equals x times y, I can now plug in 10 for x. 14 equals 10 times y. Divide both sides by 10 and get 1.4 equals y. So there we go. Not too bad. And then we follow the same thing for b. So now for b, we know that k is equal to x times y. So this time k is equal to 0.8. And then we say that 0.8 is equal to xy. So we got our equation. I guess I should put these ones in green because these are the equation. And then we have to plug in x. So 0.8 equals 10 times y. Divide both sides by 10 again. And this time 0.08 equals y. There we go. All right, and then for the last one, since x is 2, when y is 5, we say k equals 2 times 5. K is equal to 10. So we say 10 equals xy. I'm going to put that one in green because I probably should put the other ones in green for equations. Replace the x with a 10. Divide both sides by 10. And so we get y equals 1. All right, so we've solved them all out. All right, cool. One thing to double check is since we are going inversely, that means as x goes up, y goes down. So if we notice all of these, x is 7, then x is 10, so x is going up, so my y value should go down, and it does. I go from 2 to 1.4. As x goes up, 4 to 10, y goes down, 0.2 to 0.08. As x goes up, again, we're going up again on this one, y goes down. So again, 2 to 10, 5 to 1, and it's always that proportion. So we can double check our answers to make sure they make sense by following whether it's direct or inverse. Direct, they go the same direction. Inverse, they'll go opposite directions. All right. So for number 3, now it tells us that f of x is 12 over x. First thing we have to do is graph f of x. All right. So we can tell that this thing right here is in the form of, let me get a pen, y equals a x minus h plus k. I should use all my colors again. Let me rewrite that. Y equals a over x minus h plus k. All right. Now there's no parentheses, and there's nothing on the denominator of the fraction that we're adding or subtracting, and there's also no number that we're adding or subtracting on the end either. So both h and k are going to be 0 in this case. So the only thing that's happening here is we're just doing a vertical stretch by a factor of 12. 12 is a lot, but that's all we're doing is a vertical stretch by a factor of 12. So I know I'm going to have the points instead of 1, 1, 1, 12. And instead of negative 1, negative 1, I'll have negative 1, negative 12. Same deal over here. Instead of negative 12, oops, wrong place. Negative 12, negative a 12th, we'll have negative 12, negative 1. And up here we'll have 12, 1. So we're going to stretch this graph. We're going to lift it up by a factor of 12. I also know since h is 0, that I'm going to have a horizontal asymptote here. Oops, wrong way. Got ahead of myself. So h is 0, so that's our left and right. So that's our vertical asymptote. That goes with the x. All right. And then since k is 0, I have another asymptote here. Because I'm not moving the graph up or down at all. And now I just get to kind of connect my dots with the nice little swoops. So there we go. There we go. Put my arrows in to make it look even nicer. So pretty nice. And let's answer the questions. So identify any horizontal asymptotes. So since k is 0, the horizontal asymptote is at y equals 0. Identify any vertical asymptotes. Since h is 0, we can say x equals 0. Or if we think about it, if we plug 0 into the original, we're going to divide by 0. It's not going to work. State the domain. So that's all the places on the bottom where we would get 0. So what you do is you set the denominator equal to 0. So we're going to take the x and say x equals 0. And there's nothing to solve. So our domain, remember these are the excluded values, is going to be x is just not allowed to be 0. If you put the all real numbers, except x is not allowed to be 0. For the range, again, the only thing that we're going to break is this k, but we're not adding anything. So like there's a plus 0 over here. So our range is going to be everything except this value, because again, we can't hit the asymptote. So it's going to be all real numbers, but y is not allowed to be 0. So again, this means we can pick anything except 0. Now the other thing we can do is we can actually graph it in Desmos. So let's actually see what it looks like in Desmos. Let's see if my nice little graph actually works out. We're doing 12 divided by x. 12 divided by x. All right, that looks pretty reasonable. I'm going to zoom out because the graph on the paper zoomed out a little bit. And that looks pretty much like what I've got. It doesn't look like we're hitting 0. And it looks like as we go on out to infinity, we are headed towards 0. Again, if you want to zoom out a lot, you can see, okay, yeah, looks like we're at 0 and 0. So looks pretty good. Nice. So that's what we get for number 3. All right, number 4, very similar. This time I think I'm going to go the other way, though. So instead of doing everything by hand first, let's look at the graph and see if we can grab everything from the graph. So f of x is equal to 1 over x plus 3. All right. So 1 over x and then plus 3. So we can see the graph did move up. So if we look at where our asymptote is now, it looks like it's right about 3. Let me put this on the... That didn't help much. So it looks like we're right about 3. So it's 2, and there's 3 right there. Yeah, let's do this. We count by ones. 1, 2, 3. So our horizontal asymptote is at 3. It looks like our vertical asymptote is still at 0. So again, if I want, I can draw those in and then make the graph from there. So horizontal asymptote we said was at 3. Vertical asymptote we said was still at 0. So x equals 0, y equals 3. And we want to get the right shape of the graph. So let's grab the graph again. That's the wrong one again. There we go. So it looks like we're coming from the top. And so we want to pass through 1 and 1, since there's no vertical stretch. 2.5, so there's no vertical stretch. 1/2 and 2, no vertical stretch. And there we go. Again, we want to be accurate this time, because it does say graph, it doesn't say sketch. So we do want to make sure that we get the curve right. So we're not just blindly sketching. You can't just put down like 2 arcs. You have to make sure that they're in mostly the right spots. So again, we want to double check some of our spots. And you can do that if you want it on the graph by clicking and holding. So again, you can kind of see right there. Okay, yeah, that looks like that's at 1, 4. If we go to 2, down 1/2 from 4 to 3.5. If we go to 1/2, we're at 5. So those are all the points that I graphed. All right, state the domain. So again, the domain is everything, all real numbers, except our asymptote. So it's all real numbers, but x is not allowed to be 0. State the range. Well, for the range, it's going to be all real numbers except our asymptote. So all real numbers. This time y is not allowed to be 1, 2, 3. All right, so did that one two ways. So I did number 3 all by hand. I did number 4 mainly using the graph from the graphing calculator. You can choose to do it however you want if you have to do something like this, but those are both of your options. All right, so for number 5, length of the pipe in a panpipe L, so that's a musical instrument, is in feet, is inversely proportional to its pitch, P, in hertz. So it's kind of like we're making the instrument here. The inverse variation is modeled by the equation P equals 497 over L. Find the length of pipe required to produce a pitch of 220 hertz. So we can see here that our pitch is going to be 220 hertz, and our pitch is P. So we know we're going to plug the 220 in for P. So 220 equals 497 over L. Let's see, L is the length, and it says find the length. So we have to find L. So we don't know what L is. I'm going to leave that as L. So it looks like everything's in place. And just like we solved these, it's kind of like we do all the trig ones from last year. We put this over 1, and then we just cross multiply. So 220L equals 497 times 1. Divide both sides by 22. So L equals 497 divided by 22. 22.59. Seems pretty reasonable. All right, there we go. So that's our length for our panpipe. So again, this is in feet. So it means we need a 22.5-foot musical instrument in order to make the pitch of 220 hertz. So if you play instruments, you kind of know 220 hertz is not a very high frequency. So you do need a long instrument in order to have that wave travel. So, all right, so we're doing number 6. So given f of x is equal to 2x over the quantity x plus 1, which simplifies to negative 2 over x plus 1 plus 2. First thing this is asking us to do is identify any of the horizontal asymptotes. So remember, the horizontal asymptotes go with the k. So our horizontal asymptote is at y equals 2, since 2 is the value for k. So what I'm going to do is plop that in. So we'll get our horizontal asymptote at 2. Looks pretty nice. For the vertical asymptotes, again, that's kind of like our value for h in this one, but we also want to remember what we want to do is set the denominator equal to 0. And so we get x equals negative 1. So that's going to be our vertical asymptote. All right. And then part C says sketch f of x using the asymptotes. So we know usually we get something that looks like this, but we got to watch out here. So in this case, we got a negative 2 up here. So that means that we're going to flip, and there's going to be a little bit of a stretch. So our graph is actually going to look something like this. Now the nice thing is we're just asked to make a sketch. So as long as we get the general shape right, we should be pretty good. So we'll go like that. We'll go like that. And I went through 0, 0 just because I can kind of see if I plug 0 in here, I'm going to get 0. So I kind of know that point. I don't really need to do too much with it. And then I'll just mirror it on the other side, the other quadrant. And that's about it. So that's what we want to do. Should be pretty good. Again, if you want, we can check it out by plugging it into Desmos. We don't need to be perfect. We just need to make a sketch. All right. So for number 7, kind of same idea, except this time we've got a squared equation. So 2x squared over x squared minus 1, which simplifies to 2 over x squared minus 1 plus 2. So first thing we want to do, it says identify the horizontal asymptotes. That's our k value, so y equals 2. All right, and then identify any vertical asymptotes. We're going to set the denominator equal to 0. So x squared minus 1 equals 0. So we get x squared equals 1. We could square root both sides. After we added 1 to both sides, we get x equals plus or minus 1. All right, well, this is a little bit strange because now we've got 2 asymptotes. So we can't just kind of go based off of our usual. idea. So we may want to throw this into Desmos just to double check to see what it's going to look like, because we know we're not allowed to cross any of the asymptotes, but it's still a good idea. We could pick test points, but again, let's just plug it in to see what we got. I can pick either one. I think I'm going to just do the unsimplified form, so 2x squared over x squared minus 1. And so we can kind of see, all right, so this is what the shape of the graph looks like. Okay, so we're going up, down, and in the middle part, we got a parabola that hits at 0. All right, so let's go ahead and throw that in. So let's do our little parabola. It's upside down that hits at 0. Perfect. And on these sides, we're going like this. All right, there we go. So that's what our graph looks like. Kind of a cool looking graph. That's the fun things about these rational equations is that we can get some fun looking ones. So that's going to be about it. There we go. All right, moving on. Number 8, identify the horizontal and vertical asymptotes. So this time we can see we don't have the simplified version, so we can't say that there's 0, since we would have to simplify it if we want to use those familiar forms. So what we want to do is we want to take our leading coefficients from both the numerator and the denominator. So in this case, we've got 2x squared and 4x squared, so the leading coefficients are going to be 2 and 4. If we simplify that, we get 1/2. And we want to remember that that is going to be the horizontal asymptote. So our horizontal asymptote, we always want to write as the y. So y equals 1/2. To get the vertical asymptote, it's the same as the other questions. What we're going to do is take the denominator and set it equal to 0. 4x squared minus 1, we can add 1 to both sides. So 1 equals 4x squared. Divide both sides by 4. So 1/4 equals x squared. Square root both sides. Square root of 1 is 1. Square root of 4 is 2. And we get our two vertical asymptotes. So the vertical's in green, and I did the horizontal first in purple. So that's what we got. For part B, kind of more of the same. Oh, wait, before we go on to part B, we got to check. We got to make sure. I did the check kind of quick. So for this one, we do want to check to make sure that these are not holes. So you have to plug the 1/2 and the negative 1/2 in to make sure that doesn't give you 0 on the top also. So 2 times 1/2 squared is 2 times 1/4, which is 1/2. 2 times negative 1/2 squared is going to be the same thing. Since these are not 0, then we get to keep both of them. So they both work. Both are okay. All right. I kind of did the thing in my head quickly because I saw that 0 was the only option that would have given me 0. But regardless, we'll check out part B. So for part B, we do have something that's a little bit trickier. So what I want to do is I do want to change this a little bit. I want to try and factor if I can. So up here, I can tell I can divide these all by 2. X squared plus 5x plus 6, and then x minus 3, x plus 3. And this quadratic, we could factor that because we know that what multiplies to 6 and adds up to 5 is going to be x plus 3, x plus 2. And the reason that we do this is now we can see these x plus 3s are actually going to cancel out. Pretty cool. So we get 2x plus 2 over x minus 3. The reason that we want to do that is it kind of evades this whole check. So you got your choice. You can either do the factoring or you can do the check. So again, I want to do it both ways. So let's actually get into it. We have to do the horizontal asymptote. We can see it's just going to be 2 here. So again, 2x squared divided by 1x squared. So 2 over 1 equals 2 for y. For the vertical asymptotes, again, since I did this factoring pre-work, I get to work over here. I get to just say x minus 3 equals 0, add 3 to both sides, and just say x equals 3. And I'm done. I don't have to check it. If I didn't do the factoring pre-work, what I'd have to do is I'd have to start all the way back over here at x squared minus 9. So we would have to say x squared minus 9 equals 0. Add 9 to both sides. X squared equals 9. Square root both sides. X equals plus or minus 3. And I'd have to do the check now. So now I would have to go and see 2 times negative 3 squared plus 10 times negative 3 plus 12. And I would actually have to calculate it because I need to see if it's going to be 0 or not. So this is going to be 9 times 2 is 18. 10 times negative 3 is negative 30. And 12 is 12. And if I add all these up, I do get 0. So I cannot pick negative 3. Can't pick it as an answer. Then I have to check 3 because I do have to make sure it works. So 2 times 3 squared plus 10 times 3 plus 12. So I get 18 plus 30 plus 12, which is going to be 60. So we're safe. So x equals 3 is the answer that way. So again, you've got two options. I think it's a lot easier to do the factoring one because then I don't need to do the check. I don't need to plug anything back into the equation. But if you want to do it that way, you can. And then just remember, if you want to double check on the graph, you can always double check on the graph as well. So let's actually graph this one. 2x squared, so 2, 10, 12. There you go. Get rid of that. 2, 10. Remember, if you are using Desmos, you do want to put those parentheses first. It usually helps out on the TI as well. If you have the nicer TI, when you hit the division, you can definitely see which part is going to be on top, which part's going to be on the bottom. This was 3 and 3, so x squared minus 9. And I missed my x, 10x. There we go. All right, and so we can see, yeah, without that x, you can see, oh, yeah, negative 3 and 3 do work, but we have to have that x in there because I mistyped it. And that one that was at negative 3 went away. So again, that's kind of cool because we can go over to 3. On Desmos is kind of cool. You can see the hole right there. Oh, stop right there. So you can see there's a hole. So it doesn't exist there, but it's not an asymptote. Kind of cool. But yeah, our only asymptote is here at 3. So you can double check it with the graph. These ones are kind of fun. All right. Next one, so number 9, given f of x is this equation, we want to first graph f of x. So possible to do this one by hand, but based on the instructions, it looks like we're supposed to graph it first. So let's do that. We got 10x plus 20. Where is there? Let's get rid of this one. 10x plus 20. And on the bottom, we've got 10, negative 49, negative 33. Okay. All right. Well, this looks like a tricky one. So I want to find out where my asymptote is, but this doesn't look like it's going to be nice. So where are we headed towards here? So let's zoom out, see if we can see a little bit better where we're going to for the x's. So 0.617. Come on, mouse. 0.617. That's all it wants to go, I guess. 5.6, 5.6, 5.6. Looks like we're headed to 0.6. So we'll put in 0.6. That's like right there. X equals negative 0.6. All right, and we also got to check the other one. What are we by here? 5. Whoa, that flew way up. 5.5 going down. So maybe about 5.5. And over here we headed up towards 5.5, 5.3, 5.4. Yeah, probably 5.5. Why this side didn't really like me very much. That's okay. So we need another one. over here. I'll move out of the way in case I need to. All right, and it looks like our shape of our graph is up on both sides and then kind of parabolic in the middle. Oh, I need to know what my other asymptote is. That looks like that's at 0. Let's go back home. Yeah, that's pretty clearly at 0. Oh, that's weird. It looks like we're going past 0 here. Interesting. But we do want to head towards 0. So let's put that one in. See, these are so much fun when you like look at all the graphs instead of just do them all by hand and then just, I don't know. So much like curious things to look at. Anyway, this one kind of goes up like this. This one goes up and down like that. And we were kind of parabolic in the middle. And I do need to move down kind of that way. All right, pretty cool. So identify any horizontal asymptotes. We kind of did that. We said that y equals 0 is a horizontal asymptote. And then for the vertical asymptotes, we got x equals negative 0.6 and 5.5. All right, so that's pretty nice. I mean, we could do that with the graph. That didn't seem like it was too long. If you do want to do it by hand, again, it is pretty cool if you do it by hand. Again, we want to say that we have 0x squareds here. So we would do 0 divided by 10 is 0, and we do match up. So we get 0 equals y. So we can do this one just like the last question. Identify the vertical asymptotes. Same deal. If we want, we can set the bottom equal to 0. 0 equals 10x squared minus 49x minus 33. Well, what multiplies to negative 330? Negative 33 times 10 and adds to negative 49. All right, well, here it looks like we might have a little bit of a tricky problem. I think we got to get one positive, one negative. So let's pick 6. If we divide this one by 6, we're going to get 50 and then 5. Negative 55. And that does work out. I'll admit, I did that earlier, so I kind of knew which ones I was going to get. But that one might take a lot of guessing to actually get to negative 55 and 6, because those aren't really common ones to think about. Double distributive property, 10x squared plus 6x minus 55x minus 33. These both can be divided by 2x, so 5x plus 3. Is that right? That looks good. And then minus 55 minus 33 is minus 11. 5x plus 3. All right, so 2x minus 11, we take the outsides, and 5x plus 3 inside, or the two that are the same are the new GCF. We got to solve them both out. So with the zero product property, 2x minus 11 equals 0. Add 11 to both sides. 2x equals 11. Divide both sides by 2. X equals 5.5. We got it. Okay, that looks good. That's always exciting. And then with this one, 5x plus 3 equals 0. Subtract 3 from both sides. 5x equals negative 3. Divide both sides by 5. Negative 3/5 is negative 0.6. There, see, I mean, it's so nice when it all works out. These are always so good. All right, so anyway, that's how to do that one. Again, you might not choose to do this one by hand, but if you want to do it by hand, you can. There's nothing that's going to stop you. Again, this one, since it says graph first, probably going to make the graph first. All right, number 10 is very similar. So again, you can do it either way that you want to do it. Let's do it by hand. I mean, it's so much fun to do it by hand. We'll have to save the graph until we get our asymptotes, but it's just so much fun to do it by hand. So we do it by hand, we get 1x squared. So this is going to be 1 over 2 is 0.5 for y. There's a lot of dashes there. All right, and then for the vertical asymptotes, we set the bottom equal to 0. 0 equals 2x squared minus 10x minus 12. I can divide everything by 2, so x squared minus 5x minus 6. And we can factor that one a little bit quicker because things that multiply to -6 and add to -5 is going to be -6 and then +1. So x equals 6, x equals -1. All right. I don't know why I did that all in blue. That should all be in green. Ooh. How do I fix this? What's this? There we go. All right. So we'll put those in. I guess that one negative sign wants to stay blue. 6 and -1. All right. But again, since we're doing it by hand, still got to check to make sure that nothing is going to break on the top because, again, we're not allowed to get 0 on the top for these as well. So 6 squared is 36. This is not going to give us 36. 4 times 6 minus 6 is 5 times 6. So we know that one's not going to work out. So that one's safe just by double checking. -1, so this would be 1 squared plus 4 minus 6 is also not 0. So I double checked them. You can double check them pretty quickly. But we got the two asymptotes again. With the two asymptotes, it's always best to double check. So even though we got all the asymptotes, it was fun to do them by hand. Let's still just double check everything in the graph. So 1, -4, 6. 4, 6. See, look at that graph. That might not be what we want, but that still looks nice. 2, -10, -12. 2, 10. That is what we want. Look at that. See, that was pretty crazy. All right. And the nice thing is we already have all the asymptotes in, so we're just kind of looking at the shape. So we can see we're going to go down. So we're going to get kind of what looks like a regular one on the edges. So like our standard 1 over x on the edges. That was not the best, but all right. And then in the middle, that's kind of cool. We get like a kind of like a odd negative. All right. And so there we go. We're all set. So remember, we are allowed to cross the asymptote in the middle because the asymptotes are just at the end. So it's fair that one actually crosses at the middle. But our ends are never going to pass that 1/2. So pretty cool. All right. Next one. Oh, that's it. That's the whole thing. I forgot. There's only 10. All right. So I guess we're done. Pretty cool.